Hey guys, welcome to fifth episode of Mighty Kafka. Today we're gonna discuss about broker, broker cluster, zookeeper, topics and partisans. As we know that Apache Kafka is a distributed publisher subscriber messaging system, and like any pub subsystem, messages that are produced by producer should be stored somewhere in the system, right? And that is where broker comes picture. It actually acts as a bridge between producer and consumer. It stores the message received from the producer, and when a consumer made a request to read the message, the broker serves the message to the consumer. So the broker is responsible for mainly three things. First one is to receive message from producer. Second one is to store the message durably and reliably in a hard drive or SSDs. And third one is to serve the message to the consumer when they made a pull request for reading it. Also, there can be multiple producer and multiple consumer attached to the single broker, right? Let's say this is producer one. We can have multiple producer like this, and we can have multiple consumer as well, and both can be attached to this single broker like this. In this way, multiple consumer and producer can perform read-write operation parallelly and simultaneously without affecting other producer and consumer. And just remember one more thing, that each producer and consumers are independent of each other. Like this producer don't know about this producer or this producer. In the same way, this consumer don't have any information about the other consumers in the system. Now in this configuration, we have single broker, right? And this is also the drawback of it, as we have single point of failure. Let's say anything goes wrong with this broker, then the whole system goes down. Neither producer are able to produce anything, nor consumer can consume anything, right? And we have data loss. That's why nobody should use Kafka with single broker in production. To encounter this drawback, we introduce cluster of broker. Cluster of broker simply means multiple brokers are configured to work together, and the number of broker inside cluster can vary from 2 to 1000 and millions as per needed. Let's say our system has three broker P1, P2 and P3, with four producer P1 to P4 and two consumers C1 and C2, right? And for an instance, let's producer P1 produce a message 1.1, right? It produces this message. It goes to broker P1. Okay. Producer P2 produce a message 2.1. Okay. So it goes to broker 2. Now producer 3 produce a message 3.1 to broker B3. So 3.1 goes here, and P4 is also attached to broker B3, right? So let's produce a message for P4 as well. Let's name it as 4.1. Okay. So producer P4 produce this message. It goes to broker B3. Okay, it comes here. And consumer C2 gets the message first, 3.1 and then 4.1. Why in this order? Because of offset number. Since 3.1 arrives first inside the broker, so it's get assigned offset number of 0, and then 4.1 arrives and it gets offset number 1, right? But don't worry about this offset number for now. We'll discuss it later. Now let's say something goes wrong with this broker P3 and it goes down. Okay. In between that, producer P4 produce a new message 4.2 to broker B3, but broker B3 is not active now and the message should be lost. But as we have cluster, other brokers either B1 or B2 will take over broker B3, that it process the message 4.2 and the system remains functional. Have you noticed something, that even after consuming messages from brokers, the messages don't get immediately deleted and the broker is still contain it, like 1.1, 2.1 and so on are already consumed from these brokers, but the broker is still contains these messages. This is because of retention policy that is specified in server.properties. So let's just open our server properties, and that is inside Kafka directory. And when you scroll down, you find something like, yeah, log.retention policies, right? Okay. Here you find two criteria. The first one is the setting the age of the log file, and the second one is setting its maximum bytes. So these two criteria are used to delete a message, and the message gets only deleted when either its age crosses these limits that we have specified here, or its size exceeds these many bytes. And we have two more fields here in our section, like minutes and millisecond. You can specify these two, and all these things are customizable, so you can easily customize it according to your need. So till here we understand that any producer or consumer can interact with any broker, right? Like producer one can interact with any of the broker inside the cluster, and same goes for consumer as well, like it can consume messages from any broker. But you might have a question, like if this is the case, then how does messages are synchronized across brokers, right? And answer to this question is Zookeeper. And it's Zookeeper responsibility to keep everything in sync. It keeps list of active broker, it manages configurations for topics and partitions, and it elects controller for the cluster. But now let's discuss about topics and partitions. We know that a broker is responsible for storing messages, right? But where actually does this message are stored? For this purpose, we have something that is termed as topic. Each topic must have a unique name across cluster. Topic actually groups a related event together and store it durably within partitions. You can think of a topic as a central but logical concept in Kafka that basically decouples producer from consumer. Producer push message into the topics, and consumer pull the message off from the topic. We just introduced partition here, right? So partition is actually the smallest storage unit in Kafka that holds a subset of record or a message owned by a topic. A topic, of course, can have multiple partitions. Each partition is an ordered, immutable sequence of messages. Each messages, when arrived inside partition, is assigned a unique sequential offset number that is continuously appended to a commit log. Right. Let's take an example of our movie topic. Let's say our movie topic contains three partitions, P1, P2, and P3. Okay, and we are producing some movie names into these topics. The first movie name that we produce, let's say, is an Inception, so it goes to partition P1. And as we said, that whenever a message arrived into a partition, it automatically assigned a unique number. So it assigned a unique number as 0. Okay. Now we produce a message named Iron Man. So it goes inside partition P2. Again, it assigned a unique offset number 0. And when I say unique, it is inside the partition only, right? Because if you compare these two, you may think that these numbers are not unique, but across these partitions, these numbers are unique. Okay, next we produce a message named Lucy. So it goes into partition 3, and it is again assigned a number 0. Now let's say we again want to produce a new message. Let's say Thor, and it goes to partition P1. Now, as we have already a number 0 assigned as an offset for our previous message, this message will assign a number as 1. Right. So things that need to be observed here is that the offset number is unique across partition only and not across the topic. Only thing that is remaining now is how messages are spread across partitions. Right. Currently we are doing round robin fashion, because we have 3 partitions and one by one we are giving messages to each partition. And actually this is the default behavior of Kafka, but we can definitely change it, and that is something that we will discuss in next episode. So that's it for today, guys. If you have any queries, corrections, and suggestions regarding today's episode, drop a comment and please share it with your colleagues. We'll see you guys in the next episode. Till then, take care. Thank you.